Hello everyone, my name is Shruti Sahu, currently pursuing B.Tech from Sri Shantagarge Baba of Engineering and Technology, Bhusawal, Maharashtra. To begin with, I could like to thank you, Emertxe Information Technology, to providing me this opportunity to be a part of IoT internship. During this internship, we built project on IoT-based home automation solution, and I also like to thank you, a project guide, Jay Lakshmi ma'am, who taught me various concepts that are required in project. These are the content I learned through the internship and I will try to explain you. First, I will start with the introduction. Introduction to the home automation. Home automation is a construction automation for domestic mansion as a sensible home or smart house. In the IoT home automation ecosystem, you can control your device like light, fan, TV. A domestic automation system can monitor or manage home attribute, aerolites, climate, enjoyment system and appliance. It's very helpful to control your home device. It's going to be in addition incorporates domestic security such as access management and alarm system. Once it's coupled with the internet, domestic gadgets are very important constraint of the Internet of Things. A domestic automation system usually connected control device to the central hub or gateway. The program for control of system makes both wall-mounted terminal, tab and desktop computer, a smart home application or an online interference that make even be approachable off-site through the internet. Next, I have studied C programming. Use of C programming in different fields. We get information about three levels of programming: low level programming, middle level programming and high level programming. Important characteristics of C: keywords and categories. C code contain data representation. Data representation contain number system. Data representation in bit, byte, word. Basic data types are integral, char, int, floating point, float, double, modifier and qualifier. Next, condition construct. We are learn different types of conditional construction like if else, if, switch case, for loop, while loop, do while loop, break, continue. Now I have also learned many things about the operators. Different types of operators are arithmetic operators, logical operators, relational operators, assignment operators, bitwise operator and ternary operator. After this, overflow, sign numbers, underflow, sign numbers, array, pointer, function, string, storage classes and pre-procedure. Next, I have learned C++ programming. In C++ programming, we have ma'am taught me introduction to C++, C++ VSC, concept of object-oriented programming, pillar of object-oriented programming. The pillar of object-oriented programming contain abstract, encapsulation, polymorphism and inheritance. C++ future, virtual function and classes, frame functions, template function and classes, standard template library. Now, next is IoT. The word IoT is Internet of Things. The term IoT refers to the collective network of connected devices and the technology that facilitate communication between device and the cloud as well as between the device themselves. The IoT integrated everyday things with the internet computer. Engineers have been adding sensors and procedures to everyday objects since the 90s. However, progress was instantly slow because of the chips were big and bulky. The low power computer chips are called RFID tags, were first used to track expensive equipment as a computing device. These chips are also become smaller, faster and smarter. IoT systems work through their real-time collective and change of data in IoT system has three components: smart device, IoT application, a graphic user interface. The example of IoT device are connected car, connected home, smart cities, smart buildings. Next we have project requirement. Software requirement. In software requirement which we have required in this project are Arduino ID, Pixel Lab, Blink IoT app, virtual series port driver. In Arduino ID we code and Pixel Lab for stimulation, Blink IoT app for cloud server, and virtual series port driver to configure ports of serial remote tab. Next, now I will explain you about the Arduino ID. Firstly, it is an open source software. Arduino ID is used to write and upload codes to the Arduino boards. The ID application is suitable from different operating systems. It supports C, C++ language. Code we are written in Arduino ID is referred to as a sketching. Sketches save this extension .ino. It is an official software. Now look at this. It is a toolbar, an action quick action button, open file tab, code editor, status bar, console window, and board info. It is the look of the Arduino ID. Next, Pixel Lab. It is a photo of the Pixel Lab. I will explain you about the Pixel Lab. Pixel Lab is an open source real-time emulator of development boards with integrated MPLAPX above JB debugger. Pixel Lab support microcontroller from Pixim, SimWaves, UC Sims, QEMBU Stream32, QMB SIPS32, and GIPSIM. Pixel Lab has integration with MPLAPX Arduino ID for programming the microprocessor boards. As the purpose of Pixel Lab is to emulate real hardware, it does not have any source code editing support. Next we have Blink IoT app. Blink IoT app is an IoT platform for iOS for Arduino ID smartphones that are used to control Arduino via internet. We understand how to create new templates, how to add new device, how to add and select data stream, how to create icon. Next, we have embedded system. An embedded system is a combination of computer hardware and software device for a specific function. Embedded system may also function with the large system. The system can be programmable or have a fixed functionality in industrial machine, consumer electronic, agriculture and processing industry device, automobiles, medical equipment, cameras, digital watches, household appliances, airplanes, vending machine, and toy as well as mobile device are possible location for embedded system. Next we have light embedded IoT, which is also called as LED. Simple device used in most on the embedded application feedback work just like a diode, low energy consumption, longer life, smaller size, faster switching, make it usable in wide application field like home lighting, remote control, displays, and many more. Now it is used this is used in the project of garden lights. The property of LDR sensors are appliance to the occupiers the controlling of gardens light. Now CLCD, most commonly used to display ASCII character. Some customization in simple symbols possible. Communication mode, 8-bit mode, and 4-bit mode. Now we have next LDR, which is known as light dependent register. The light dependent register, as a name state, is a special types of resistor that work on the photoconductivity principle. Means that resistance changes according to the intensity of light. Its resistance decrease with an increase in the intensity of light. It's often used as a light sensor, light meter, automatic street light, and in area where we need to have light sensitivity, it is also called as a light sensor. Next, the project is based on the IoT based home automation. Through this project, we have learned how to control the temperature system in house, garden light, volume of water in cereal tank. Now being with project. First, I will explain garden light. During the day, the outdoor light is a maximum, so LDR sensor detect the light and garden light is turned off. On or off and brightness of light are handled here, where at the night the outdoor light is low so that LDR sensor detect the light and light is turned off. The property of LDR sensor are appliance to the occupies the controlling of garden lines, and during the day the outdoor light is a maximum so that LDR sensor detect this light and the garden light is turned off. Whereas in the night we can see that the light is very low, so the LDR sensor sense and detect the lights and it turn off the light automatically. After we have serial tank, read the volume of water in the tank through the serial communication and display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and outlet valve by the sending commands through serial communication. Display the volume of water in the tank on the CLCD and also on Blink IoT app. It shows temperature and volume, and it is the water tank, and it is a home automation Blink IoT app. Now temperature system. The temperature system control consists of heating register on LM35 temperature sensor and a cooler. Control the temperature on or off the heater and cooler through the Blink IoT app. The feature of the system is that the temperature reaches 35 degrees Celsius, heated turn off automatically. To avoid more heating, the notification of the same is displayed on the terminal of Blink IoT app. The feature of this system is that as the temperature reaches 35 degrees Celsius, heated turn off automatically. To avoid some heating, notification of the same is displayed in the terminal of the Blink IoT app. Now conclusion. Using Blink IoT application and Pixel simulator, we simulate home automation where LED, temperature system, serial tank resemble light, heater, cooler and water tank is real time. CLCD acts like a dashboard used for displaying the event. Widgets for Blink IoT app like a button widgets are used to control heater, cooler and inlet valve and outlet valve. Gauge lights are displayed the temperature and volume of the water. Hence the project provides perfect solution for home automation. Thank you Emertxe Information Technology for making this project successfully. Now I am going to give demo of your project. This is your code for your project for home automation system. First of all, in this code include all the required header files and libraries. We have including these libraries in the starting of the main file, and we have to write your authentication code to Blink IoT app to connect with system. Here we connect. This is our including header files. Here we connect your Arduino Uno boards, and we have to be load this code with hex file in the Pixel lab, and this is your whole code. Now we'll show Pixel Lab and this is your Pixel Lab. Here we can see temperature, volume, and we can able to inlet value is on or off. Then we are having LED sensor. It show temperature and volume. Arduino boards can not be connected with internet, so that we can need a extra peripheral, that is Ethernet sheet, which is your Ethernet sheet which is connected your Arduino boards with the internet, and this is your temperature sensor. Now I will show my Blink application app. I have created two tabs. Tab 1, on or off button. One button for cooler and second one for heater, and which have temperature same as include, and we will get notification in the tab 2. I have created two button, one for inlet value and second for outlet value. Gauge to show water volume, which is same as LCD. Connect, disconnect. There we are having water tank. Reset Pixel Lab. Now inlet value. Now inlet value is on and tag started filling. We can see volume is displaying on this gauge and also CLCD dashboard. When water is full, inlet value automatically turn off and get notification in the Blink IoT application. This is your notification show here. When we turn on the outlet value tank, it started empty. When volume become less than 2000, the inlet value turn off automatically, and also we get notification here. Now next we require control garden lights. Here I am varied the sunlight. When we have more sunlight, LED turn off, and we have less sunlight, LED turn on. Here we have temperature sensor. See, the temperature rises when I turn off the heater, then temperature started falling slowly. When I turn on the cooler, then temperature started falling. Fan started when I turn off the stop rotating. I will show it. You can see that cooler started rotating. Now off. I started, temperature rises. So like this we can control the heater and cooler through IoT application. Temperature is above 35 degree Celsius, turning off the heater. Notification, you can see that notification in the Blink IoT application. It is all about your project. Thank you.